talk about something called random forests. So random forests are fun. These have a lot of tree puns, which I think is very fun considering we're fitting decision trees. But random forests basically provide an improvement over the bagged trees that we just talked about by a tweak that basically decorrelates the trees. So it's similar to bagging, except it adds this small tweak that makes it slightly better. So by decorrelating the trees, it actually reduces the variance even more when we take the average across all of the trees. So this is the process. Like bagging, you build a number of decision trees on bootstrapped training samples. But each time the tree is split, instead of considering all predictors like bagging, so instead of considering all potential predictors, a random selection of M predictors is chosen as split candidates from the full set of P predictors. And so the split is allowed to only use one of the M predictors instead of picking from the entire set of predictors. And a fresh selection of M predictors is taken at each split. So it always is going to be the same number. For example, let's say we had 10 predictors in our model and we set M to 3. We would always look at three predictors at each split, but it might be a different 3 each time. And so typically we pick M to be equal to the square root of P. And so if P was 9, the square root of 9 would be 3, so it would be something close to that. Okay, so let's say you have a data set with 100 observations and 9 variables. If you were fitting a random forest, what would a good M be? So I want you to think about this question and answer it in today's application exercise, which you can find via the website. And so go ahead and answer this question there.